Hello? This video will take a closer look at regular expressions, also called patterns in Kapao Catalyst. The first half of the video will be a lecture-like presentation of the syntax, including wildcards, sets, subpatterns, repetition operators, alternate subpatterns, and subpattern references. The second half will go through 3 examples in Design Studio, using patterns to create conditions and tag finders, and to perform data conversion. If you're already familiar with regular expressions, you might want to skip directly to these examples. As mentioned earlier, regular expressions are called patterns in Kapao Catalyst, and will be referred to as patterns for the remainder of this video. The wildcard. A pattern is a way to put a string of characters into more general terms by using symbols to represent strings of characters. You might be familiar with the concept of doing searches on your computer, where it's sometimes possible to use a wildcard symbol to represent any character. Doing a search for CA asterisk, the asterisk here being a wildcard, it might return both cap, car, can, and so on. Patterns embrace this same concept while expanding to more extensive syntax, which we will present in this video. Kapao Catalyst uses the Perl 5 syntax for its patterns. In this syntax, the wildcard character is symbolized with a dot or a period, which corresponds to any single character, including all symbols, white spaces, and any other special character you could think of. This correspondence is called matching. So the pattern CA dot, for example, matches cap, car, and can like before. Or any other string which is a C followed by an A followed by any single character. Similarly, the pattern .A dot matches nap, tan, sad, or any other string of characters which has 3 characters and an A in the middle. It does, however, not match and, for example, since each dot in the pattern has to match up against exactly 1 character. Similarly, it does not match cans since the pattern has to match the entire string, not just part of the string. We can test whether a pattern matches a given string directly in Design Studio by using the pattern editor. The pattern editor can, for example, be found by inserting a test tag step into a robot and clicking Edit below the pattern field in the step action view. The pattern editor has 3 sections. At the top, it's possible to type in a pattern. The pattern is then matched to a string typed into the input field on the left. Clicking the test button or using the shortcut Ctrl-Enter will tell you whether the pattern matches the input. Try typing .A dot in the pattern field and can in the input field. Then use Ctrl-Enter. The output field will now display the pattern matches the input. We can ignore the rest of the output for now. If we, on the other hand, type just an in the input field and press Ctrl-Enter, we receive the message that the pattern does not match the input. As I go over the pattern syntax, try to experiment with the pattern editor to test your understanding of the material. Although not stated explicitly, we are now able to match in 2 different ways. Either we can match character to character. As example, the pattern A matches the string A. Or we can use the wildcard symbol dot to match any character. Additional direct character matches include the ones listed in the table here. We can, for example, match a line break character, a carriage return character, a tab character, a period, or a backslash. Any other symbol used by the pattern syntax can also be explicitly matched by preceding it with a backslash. Sets. Next step is to match a semi-known character. By semi-known, I mean that we only want to match the character with 1 character in a set of characters. A set of characters is stated in a pattern by using brackets. An example is ABC within brackets, in other words, the set of ABC. This will match to either A, B, or C, but will not match to any other characters than these three. If you wish to include a range of characters to a set, it can be done by using a hyphen. The set of A, B, C can therefore be written as the set of characters A through C. In other words, the set of characters A through C means match any character in the range from A to C. The two ways of defining sets can be combined to get something like the set of A through D, K, and X through Z, which is similar to writing out all those characters in a set, or saying match any character which is either in the range A to D, is K, or is in the range X to Z. It is also possible to define sets negatively by using the caret at the beginning of the set. An example is the negative set of A through C, which will match any one character excluding A, B, and C. In the pattern editor, try using sets to match any digit, any whitespace character, or anything that's not a digit. You can pause the video if you want to take a moment to think about these problems before seeing the answers. There are certain shortcuts for sets that are often used. Here is a table showing some of the most important ones. We can, for example, match a number with a \d, a non-number with a \D, a whitespace character, a non-whitespace character, a word character, and a non-word character. In the middle column, you can see which set each shorthand form corresponds to. Note that the shorthand form can also be used inside a set. For example, the set of all digits and all whitespace characters. Subpatterns. Next, we will need to talk about subpatterns within patterns. Terms we've talked about so far, such as the character, a set of characters, an escaped character, or a wildcard, can each be seen as a subpattern. Alternately, we can create our own subpatterns by grouping together other subpatterns by using parentheses. We could, for example, create a subpattern from the set of CTB followed by AN by writing parentheses around this pattern. It is important to recognize subpatterns, since I will now be introducing some operators which work on the entire subpattern they succeed. Repetition operators. Operators in patterns allow us to match repetitions of a subpattern by following them with one of the operators given in the table. The repetition operator is given on the left, and the meaning of this is given on the right. With the first operator, we can match between m and n repetitions. With the second, we can match m or more repetitions. For example, the pattern A repeated one or more times would match the string A, or any number of repetitions of A in the string. This pattern is a bit more complex, but it would match banana, babana, nabana, or any other string of either B or N followed by A, repeated 3 times. Try it out yourself. As for sets, there are also shorthand versions of the most useful repetition operators, such as an exact number of repetitions, 0 or 1 instance of a subpattern, any number of repetitions of the subpattern, and finally, 1 or more repetitions of the subpattern. Both shorthand and longhand versions are shown in the table. Try using what we've learned so far to match anything, either colors spelled without a U or colors spelled with a U, or any 4-digit number. The answers will follow. One of the often used patterns is dot asterisk, which matches anything, any string, even if it's empty. Now try extending this a bit. Find patterns that match any text containing at least 1 digit, any text containing just 1 digit. Here is a list of the syntax you might need. And here are the answers. The syntax used in the answers is very useful for matching specific subpatterns within a string. Alternative subpatterns. We discussed how to match alternative characters earlier, but what about matching alternative subpatterns? If we have n subpatterns, P1 through Pn, we can match any one of these subpatterns using parentheses and vertical bars separating those subpatterns. The pattern given here would, for example, match either ABC, AAAAA, or any number. Try using alternative subpatterns to make a pattern that matches a string which does not contain just one digit. Here, again, is the syntax you might need. And here's the answer. There is no not operator in the syntax. Instead, the answer uses two alternatives. The first alternative matches a string with no digits. The second matches a string containing at least two digits. Subpattern references. The last major part of the syntax to cover is subpattern references. Any substring S1 through Sn matched by a parenthesized subpattern P1 through Pn in any one pattern can be referred to by using \1 through \n, where the subpattern is numbered in order from left to right as they're stated in the pattern. Matching, for example, this pattern to cat, we could use the reference \1 to refer to C and \2 to refer to @. The entire pattern can always be matched by \0. Notice here that we're referring to the string matched by the subpattern rather than the subpattern itself. A reference to the subpattern ABC would of course yield ABC, whereas a reference to the subpattern \D would only match whatever digit was matched by the original subpattern. As an example, consider matching a string containing a quote by using the pattern anything followed by a single or double quote, followed by anything, followed by a reference, followed by anything. This may look confusing, but the only thing you really need to notice is that the reference will match the same type of quote which was matched by the first subpattern. In other words, this pattern would match both the string he said hello with double quotes and he said hello with single quotes. As I will show you later in Design Studio, subpatterns can also be referred to in certain expressions outside of patterns. This is useful when extracting certain parts of a matched string. Taking our quotes example, we could add parentheses around the subpattern enclosed by quotes. Now we are able to extract the quote in Design Studio. Here is another problem. Try using pattern references to match 4 of the same digit, a string where at least 2 characters are the same. Here are the tables with useful syntax. The answers are given here. When using subpattern references, it is handy to know the following. By default, the repetition operators asterisk, plus, curly braces will match as many repetitions of the preceding pattern as possible. You can put a question mark after the repetition operator to instead match as few repetitions as possible. Try matching a subpattern to the first occurrence of a digit in a string. The answer is given here. Removing the question mark will result in matching the subpattern to the last occurrence of the digit in the string instead. Now that we've learned the syntax of patterns, it is time to look at the various use cases in Design Studio. Conditions. Creating conditions is the first way of using patterns intelligently in robots. The test tag step action is particularly relevant in this context, so let's go over some common use cases. Here I have a robot which extracts from LinkedIn all engineering jobs they have listed for Denmark. The robot uses a loop to extract the URL, title, and company name from each job and return them to the user. Let's say I only want to extract from jobs which contain the words Copenhagen and software, indicating that they're probably looking for a software engineer in Copenhagen. First, I insert a new step after the for each step, and assign to it the test tag action. I ensure that the tag finder finds the entire job post of the current iteration of the loop. Then I iterate through the loop until I find a job offering which matches the criteria I am about to set. This makes it easier to test that the pattern I write will actually work. Going to the Action tab in the step view, I first choose to match against text only, not the entire HTML. Then I press Edit on the pattern. I am now in the pattern editor, and I can type a pattern to be matched. Since I do not know the order in which the two words software and Copenhagen might occur, I need to make two alternative sub-patterns. In the first alternative, I have Copenhagen followed by anything followed by software. In the second alternative, I write the same but in reverse order. Finally, I add any text before and after the alternatives, and press Ctrl Enter to test whether the pattern matches. It matches. I close the pattern editor and set the test tag step to skip the following step if the pattern does not match the found tag. This way the job post will be skipped if it does not contain the two words specified. I now go ahead and run the robot in debug mode. As expected, only few results are extracted, and they should all contain the two words software and Copenhagen. Tag finders. Patterns can also be used in tag finders. This can be very useful if you know the structure of the information you're looking for, but you do not know where on the page it's located. This robot, for example, goes to multiple different sites to extract the price of a certain pair of headphones. Since we cannot know where on the page to find the price, patterns play a crucial role in determining exactly this. Let me show you how to set up the extraction step. I'll delete the one I already have, insert a new step, and choose for it the extract action. To configure the step, I start by inserting a number converter, which extracts the number from any text I might extract. Then I choose to extract into the price attribute of the variable I have made for this robot. Going to the Finders tab in the step view, I click the plus to add a tag finder. I locate the price on the page. I can see that it is secluded in its own tag, with nothing else in that tag. This is typical, so we will let our pattern match this case. In the Finders view, there is a field called Tag Pattern. Immediately, we can write the pattern $, followed by one or more digits or dots. The pattern is designed to match any tag containing only a $, followed by a decimal number. I click the magnifying glass in the upper right corner of the page view, which shows me what the tag finder finds. Unfortunately, it finds the cart balance instead of the headphone price. The cart balance will always be $0 for these kinds of sites, so to avoid this mistake, I will ensure that the first digit in my tag is not a 0. Fortunately, the steep price on headphones ensures that the price will never start with a 0. Rewriting the pattern, I get $, followed by a digit which is not a 0, followed by one or more digits or dots. This finds the correct price on the page when I click the magnifying glass. Before testing the robot, I go to the error handling tab of the extract step and choose to ignore and continue on error. If the tag finder fails to find the price on the page, it should just return the default value of the price attribute, which I have set to -1. This gives me a clear indication that the robot was not able to find the price. Going to debug mode and looking at the results from an earlier execution of the robot, we see that many of the prices are extracted correctly. The method is of course flawed, but it can be surprisingly effective at times. Data conversion. The final use for patterns is to convert data from one form into another. For this, we can either use one of the data converter lists embedded in a step, or use the dedicated convert variable step. In this very simple example, I am extracting the author and date from a blog post. Unfortunately, the two pieces of information are contained by the same string of text and are therefore extracted collectively by the extract step. I will now show you how to separate these two pieces of information using patterns in data converters. The extract step has a data converter list located in the step view. The data converter list can be used to convert the extracted text before it is assigned to a variable. I click the plus and choose extract to insert a data converter which can extract part of the string. A new window opens where I can configure the extract data converter. At the top, there's a pattern, and at the bottom, there's a test input and a test output, similar to those in the pattern editor. The idea with the extract converter is to write a pattern which matches the entire input string, and then specify the subpattern to be extracted by using parentheses. By default, the entire string is matched and extracted, resulting in identical inputs and output strings. If I want to exclude some of the extracted string, I just have to write it outside the subpattern. Let me precede the subpattern with any text followed by a space, by space. Now the entire string is still matched, but only the name of the author will be part of the substring, and therefore the author's name will be extracted as shown in the test output field. The plain text by forces the two instances of any text to match the date and the author name respectively. I can now close the configuration window and execute the extract step. The author name is now correctly assigned to my variable. Let me go back to the extract step and quickly demonstrate another converter which uses patterns. I remove extract and add the advanced extract converter instead. Then I write the same pattern as I used before, except that I make a subpattern of both instances of any text. The test output is now still the same as the test input. This is because advanced extract enables me to choose which subpattern I would like to extract by using subpattern references in the output expression field. In expressions, subpattern references are made by using the dollar symbol, followed by the reference number. Right now, the expression refers to the entire matched pattern, but if I change it to $1, I only get the first subpattern extracting the date. And if I change it to $2, I only get the author name, which is matched by the second subpattern. Note that it is also possible to add text, combine subpatterns, and do simple string manipulation using the expressions field. For example, I could write an expression which recombines the two strings, but in reverse order. For more information on expressions, click the question mark next to the expressions field. Finally, I would also like to recommend the replace pattern data converter, which replaces instances of a specified pattern in a string. Those were the final words on patterns. Feel free to review any parts of the video you found useful or go to help.kapowsoftware.com to find even more answers.